Welcome to Sweet Life Beat Life. We hope this video helps.
You begin by selecting the core hardware. Pick a low-power ARM MCU and choose a 1.3 display that matches 3.3V logic so voltage conversion isn't needed. Once chosen, lay out sensors, accelerometer, gyro, heart rate, near the antenna to reduce interference, and mount a 300-500 mAh rechargeable battery with a fuel gauge IC. Now wire power rails and common ground and flash a basic bootloader. This proves communication and makes future firmware updates simple, and once bootloader runs, set up your firmware architecture. Choose an RTOS or lightweight scheduler so UI, sensor sampling, and Bluetooth run independently. Implement the BLE stack with a proper GATT layout for notifications and device control, and test pairing flows early to avoid later regressions. Meanwhile, design a minimal UI of 3 to 5 screens, make animations short and sparse to save energy, and buffer touch or button input to debounce. Make sure to log telemetry to diagnose timing issues. You finish by integrating the PCB into a sealed enclosure, routing antenna clearance and thermal vents as needed, and securing connectors so flexing won't break solder joints. Then perform power optimization, use dynamic clock scaling, batch sensor reads, and implement aggressive screen dimming, because that directly extends runtime. Once done, run 24 to 72-hour battery tests and validate BLE range and sensor calibration. If you see rebooting or BLE dropouts, check power rail noise and tighten decoupling capacitors first.
Thanks for watching. Consider subscribing if we helped you.